Welcome to Celebrity Investing, your go-to source for insights, tips, and updates on navigating the exciting landscape of personal and global finance. Please like, share, and subscribe for more exclusive content. This is part 1 of Regression Analysis Explained: Tools, Techniques, and Real-World Applications. Have you ever wondered how relationships between different factors can be measured and predicted? Regression analysis offers a clear way to do just that. It's a statistical method used to understand how one variable influences another. Widely applied in fields like economics, healthcare, and social sciences, it helps solve real-world problems by identifying trends and making predictions. Whether you're analyzing sales data or assessing medical outcomes, regression analysis simplifies complex patterns into actionable insights. What is regression analysis? Regression analysis is one of the most important tools in statistics, widely used for understanding relationships between variables. At its core, it's a method to examine how one variable, dependent, changes based on another variable, independent. Think of it as finding patterns in data to make predictions. Whether you're working with sales numbers, weather data, or any measurable metric, regression analysis helps connect the dots in meaningful ways. Overall definition. Provide a succinct definition of regression analysis and its primary function. Regression analysis is a statistical approach used to identify and measure the relationship between two or more variables. The main goal is to determine how one variable influences or predicts another. In simpler terms, it tells you whether and how changes in one factor correlate with changes in another. For example, want to know how studying hours impact exam scores? Use regression analysis. Curious if marketing spend increases sales? Regression analysis helps you figure it out. The technique builds equations, known as regression equations, that show the connection between variables, letting you estimate outcomes. It's a must-have for anyone working with data, regardless of the industry. Historical background. Discuss the origins of regression analysis, highlighting key figures such as Sir Francis Galton and Carl Pearson. Regression analysis has deep roots in statistics and dates back to the 19th century. The term, regression, was first introduced by Sir Francis Galton, a British polymath. He studied the relationship between parents' heights and their children's heights, noticing a tendency for extreme traits to move closer to the average in the next generation, a phenomenon he called regression to the mean. Building on Galton's work, Carl Pearson, a pioneering statistician, formalized much of the mathematical framework for regression analysis. He introduced several key concepts, including correlation coefficients, which measure the strength and direction of relationships between variables. Together, Galton and Pearson laid the foundation for modern statistical techniques, turning regression analysis into an essential tool for data science. Their contributions aren't just historical. Their ideas are still central to the way we analyze relationships in data today. Without their work, much of modern predictive analytics wouldn't exist. Types of regression analysis. Regression analysis isn't one size fits all. Depending on your data and objectives, different types of regression models can be applied. Below, we explore the most common types, their formulas, and when to use them effectively. Simple linear regression. Simple linear regression is the foundation of regression analysis. It examines the relationship between one independent variable, predictor, and one dependent variable, outcome. The goal is to predict the dependent variable based on the independent variable's value. The formula is straightforward. Y equals beta plus beta x plus epsilon. Y, dependent variable, the outcome you're trying to predict. X, independent variable, the predictor. Beta, intercept, value of y when x equals 0. Beta, slope, rate of change in y for every unit change in x. Epsilon, error term, variation not explained by the model. A common use case is predicting sales revenue based on advertising spend. If x represents advertising dollars and y represents revenue, you can determine how much revenue increases with every additional dollar spent on advertising. Multiple linear regression. When there's more than one independent variable influencing the dependent variable, multiple linear regression steps in. It's well suited for scenarios where a single factor isn't enough to explain changes in the outcome. The formula expands to y equals beta plus beta x plus beta nexon plus epsilon. Here, xn are the independent variables. For example, predicting house prices might require considering several factors, like square footage, number of bedrooms, and location. Each variable contributes uniquely to the model, and together they improve the accuracy of predictions. Polynomial regression. Not all relationships in data are linear. That's where polynomial regression comes into play. It models the relationship between variables as a curve rather than a straight line, making it ideal for nonlinear trends. The formula is y equals beta plus beta x squared plus beta nx to the power of n plus epsilon. The variable x is raised to higher powers, squared, cubed, etc., enabling the model to fit data points with more complexity. For instance, if you wanted to analyze population growth over time and the trend isn't linear, a polynomial regression could give you a better fit. It's particularly handy in domains like physics and economics, where relationships between factors often follow curves instead of straight lines. Logistic regression. Logistic regression is different. It's used when your dependent variable is categorical, especially for binary outcomes, e.g., yes, no or 0/1. While it's still called regression, it's technically a classification model. Instead of predicting continuous values, it estimates the probability of an outcome occurring. The formula involves the logistic function p equals 1 plus e caret beta plus beta x plus beta nexon. P, probability of the outcome. E, base of the natural logarithm. Common applications include predicting whether a customer will buy a product, yes or no, or whether a patient has a disease, positive or negative. Fields like medicine, marketing, and social sciences frequently rely on logistic regression to guide decision-making. Ridge and lasso regression. When datasets have highly correlated independent variables, a problem called multicollinearity, standard regression models can struggle. Ridge and lasso regression are advanced techniques designed to address this issue, improving both model stability and prediction accuracy. Ridge regression adds a penalty to the regression equation, shrinking the coefficients of less significant variables. This reduces the risk of overfitting and is particularly useful in datasets with many predictors. The penalty term is L penalty equals lambda n area summation, beta squared. Lambda controls the strength of the penalty. Larger lambda values reduce coefficients more aggressively. Lasso regression. Similar to ridge, but it can shrink coefficients to 0, effectively performing variable selection. If you have many variables and need to identify the most important ones, lasso is a go-to tool. Its penalty term is L penalty equals lambda n area summation, beta. These methods are widely used in machine learning and predictive modeling, where datasets often include tens or hundreds of variables. By simplifying models, ridge and lasso ensure accurate predictions while preventing unnecessary complexity. Each type of regression offers a unique way to uncover insights from data. Whether you're modeling a straight line, a curve, or predicting a category, the right method depends on your specific needs. Applications of regression analysis. Regression analysis plays a vital role across various industries, helping professionals uncover patterns and make informed decisions. Below, we explore how this powerful tool is applied in economics, healthcare, and social sciences to address complex problems and guide strategies. Stay tuned and continue to watch our videos to gain valuable insights into the world of finance. Subscribe, like, and share to continue your journey to financial success.